Okay, thanks everyone for coming. My name is Jackie Boone. I'm from an art collective called Art Make Us. We are a collection of sound artists, programmers, designers who create some things every year at Maker Faire or even art science museums. Actually, we have two of our members there, Zach and Mitru. Yeah. So Zach is a designer and Mitru is one of the programmers as well. So today I'm going to give a talk about the imitation game. So how many of you knows the imitation game? Raise your hand.
The movie?
The movie, yes. Okay, not too many. Okay, so what we did at recent Maker Faire 2015 is to create a machine. Do you know the Enigma machine? How many of you know Enigma machine? Okay, good. So we create something called the Bombay, and how many of you know the Bombay? Okay, only one. Good. Okay, Bombay is basically the machine that Turing created to decode the Enigma messages. So that's what we are trying to create this year, and we did. And a few notes before we start, feel free to interrupt me because this is my first talk ever at the project. This is just a high-level overview, so I'm not going to specifically talk about any JavaScript framework. There's a lot of languages involved in this project, so JavaScript will be one of the focus near the end of my slides. And this is not a best practices talk. Slides, if you guys are interested in the slides, it's available at the VNCO ZURL. Alright. So this is the thing that we built. Anybody recognize this pattern? Okay. No, you recognize it because you know the Bombay machine, which is the machine that Turing created. So this is the Bombay machine. So the Turing created this machine to decode messages by rotating each of the motors, and each of the motors refers to a specific settings. So yeah, we exhibited. So this is our machine here, and we have tons of Arduinos. And that's me through there, talking with one of the audience. And we have some kids as well interested in how it works. So, first thing is I'm going to give you a very brief explanation of how the Enigma machine works. So basically the Enigma machine is composed of a keyboard, where the people will type in their messages. So the German actually use the Enigma machine to type messages over radio, and each letter will actually correspond to will result in different letters. So for example, A is mapped to this pin, and then you go all the way, and then once it reaches the reflector, it will actually reflect to another pin, and it will go to, for example, go to D, I guess. So when you type A, the result is D, and something. So we did I did a quick algorithm implementation in Go. So sorry, it's not JavaScript, but later I will tell you about the job. So for example, we have AAA here. If you run the code, it's actually result become BDZGO. And the interesting about this is the Enigma machine, because of the reflectors, it is able to reflect back the messages. So from AAAA is encrypted as BDZ0, and then you encrypt it again, it actually turns back, become the original message. And one weakness of the approach is you cannot encrypt the same letter as the same letter. So you cannot encrypt A as A. That's one weakness of the Enigma machine. I'm going to show you the first prototype that we did. it's actually composed of Go for the Enigma part, the processing, and we have processing. How many of you know processing? Okay, well, not too many. Okay. Processing, basically what the role of processing is to control the Arduino to serial port. So I'll show you the video. So these are simulation, and these messages is actually encrypted messages from Twitter. So we actually receive tweets from specific hashtag, and okay, so this is actually Justin Bieber's hashtag, and I use it because it's very popular. It's very easy to get messages. So we encrypt it within the software, and then once we encrypt it, we try to decode it with the machine. This is the actual hardware prototype. Gosh. Sorry. So this is the simulation, and this is actually the hardware. So you will see that both of them will run at the same time. And we have so we have 11 Arduinos. So we have this is the USB ports that we needed to use. So this is the overall stack, the overall framework that we use. So we have Go just to receive and encrypt the tweets, and simulate the Bombay, broadcast the Bombay through OSC, and then the processing will actually listen to the Go program and controls the Arduino. And on the web part, we actually use WebGL to render the simulation. And Arduino is obviously control the motors. So what the disadvantages that I found with this approach is we actually use a fixed serial port. So whenever you unplug and replug the Arduino, it's actually the names changing. At least in Linux. On Mac, I don't know. And there's so many programs to run. We have Go, we have processing, we have browser. And if you unplug the Arduino where the program is running, it's busted. And so this is the second prototype that we did, the Maker frame. So you see it actually intercepted a secret message, and each of these is actually a line of decrypted messages. So every single motor is doing work. For the second model, we actually use Electron, React, and not serial port, because the advantage of this part is we have a proper API for disconnect and connect and disconnect serial port events, and it helps because we have so many Arduinos, we don't know which one is which. So we needed to identify them, and there's only one program to run. So this is the React app that was written. So as you can see, it's very simple, very straightforward. You have on serial connected, on serial disconnected, and then we handle that. This toggle Bombay is basically just turn off and on tweet is when you receive a new tweet. And then this is the Arduino code. I removed some of the code to be simple. So we actually identify each Arduino by writing very simple. We just if it's the top part of the Arduino, because we have 3 rows, we identify each row with top, middle, and bottom. So to know which one is the top, we just say it's the bottom one or is it the middle one, and then the tag on the React app. So on serial connected, if it's either top, middle, or bottom, then we connect it. Then we know it's our Arduino. And this is the status panel basically. It's just to list what is connected, what is not connected. I actually give you a quick demo of the software. So this is what we have. So to explain what I did is I'm going to demo simple plug and play Arduino program. Hopefully it works. So as you can see, it detects the bottom part of basically the machine. So I programmed this Arduino to be the bottom. So it's very simple. And you can change the, let me see, what's trending on Twitter right now. Ask Jack, okay. Ask Jack. Takes a while. Maybe actually.
Tweet, guys.
Okay, it's still not going. Let me try that. Okay, bigger one. So this is the encrypted message from some guy now. And this is all the lines of possible outcomes of the settings, individual settings of the motor. It'll take about 1 or 2 minutes to complete the decoding process. So what it does currently is basically just using the machine to brute force all the possible settings through the rotation of the rotors.
Is it randomly generating the text?
No, it is actually the individual settings, and then we pass through the message through the settings, and that's the output. So this is the output that we found. But there's no space because the Anima machine doesn't support space.
Did you determine this on dictionary? Or?
This we use the touch tag as the keyword basically.
So how do you determine which one is the right one?
Because we use brute force, right? We keep finding all the possible outcomes if it contains that hashtag.
Oh, right, the dash.
Yeah.
That makes sense.
It
That's the hashtag.
Oops.
Yeah.
What was the hashtag? I didn't see.
Yeah, it makes sense.
Okay, there's another one. That's really it for me. If you guys have any question, just ask away.
Why do you need
So, what did you learn from this? Like, what practical application does this have? I don't quite mean that, but I mean sort of like, what can you extract from this? Or was it just purely just academic?
It's purely academic, to be honest. We could have just used the Go processing, the web browsers, and it will just all work. But we wanted something simple to deploy. So we wanted just to deploy a single application. So it's good to just package all of them up in one single language and one single file. So what I have here is actually so what all I have to do to start the program, everything is basically just double click the binary and it is already running. So I guess the main lesson from it is, well, I needed something easy to run. I need something easy to, everyone can code for it. So I chose JavaScript, and React seems like a good framework to work on. Yeah.
How many combinations is it brute forcing? I thought this Enigma was like in the...
There's supposed to be 108 divided by 3, so it's 36 different Enigma machines.
And then, but how many possible permutations are you brute forcing?
It's actually 26 times 26 times 26, so I guess about 10,000. But
The real Enigma machine had a lot more combinations.
the real one, they initially have 3. Okay, so back to the slide. Okay. So the real Enigma machine have 26 of these. So these are only 6. The real one have 26, and the real one also have only 3. So 3 is like 26 times 26 times 26, and then they improve it. Yes. For the naval Enigma machine, they actually increase this number to 8. But we didn't want to do that because it takes too long for people to get the result. So we just do 3. And we didn't do the hardware. By the way, you guys can read this book by Simon Singh. It's very good book. If you are interested in cryptography, the book explains about the Caesar cipher, which is very simple, and the Enigma cipher, and the pretty good privacy cipher, the PGP. And
It's actually a similar question.
similar.
So it's a similar question. You can answer the question.
That's all right. I guess it's